everyone and welcome back to Diksha Karnataka YouTube channel. Today is Sunday, so at night I am here with the solution of your KCET Premier League Physics question paper number 9, and if you have not yet downloaded the question paper, don't forget to visit our WhatsApp channel. The link is given in the description. From there, download the physics paper that was given in the morning, and then you can go through the question paper quickly before you can watch this video. Here I am going to discuss all the problems, all the solutions in detail. Today, as discussed, we are having 2 first few chapters and 1 second few chapter as a revision. So let's start with the first question of today. If x equals to a bt plus ct square, where x is in meter and t is in second, then what is the unit of c? Very interesting and simple question, that x is given a bt plus ct square. Now you don't need to find velocity, you don't need to find acceleration from here. What you need to do, you have to find the unit of unit of c. Okay, now you should know that if the left hand side has a unit meter, all the individual terms on right hand side should also have the unit meter. Why? Because you can only add terms having same units, right? So here a should be meters, bt should be in meters, ct square also should be in meters. Now ct square should be the unit of ct square should be in meter, but out of that t square has a unit of second square or time square. So what we can say that, let me write in terms of unit, not in terms of dimension, so don't get confused. So t square has a unit of a square, so we can say that c times second square equals to meter, or c equals to meter second to the power minus 2. That is basically it's an acceleration, so meter per second square is the answer. Simple question, okay, based on units chapter. Now let's move on to the next question. Young's modulus of a material has the same unit as that of, so Young's modulus has the same unit that of pressure. Okay, I discussed that while teaching the chapter, also solving the previous year question. So this is an easy question. So unit of Young's modulus is same as pressure. Now, two quantities x and y have different dimensions. Which mathematical operation given below is physically meaningful? So x and y have different dimensions. Okay, so suppose one is in meter, another one is second. Okay, so if x is suppose in meters, y is in seconds, can you add them? No. Can you subtract them? No. Can you say okay meter equals to second plus 3? No. You cannot write in terms of equation as well. Only thing that you can do, you can divide x by y. So meter per second is the unit of velocity. So division and multiplication between the dimensionally different quantities is possible. Addition, subtraction, or writing in an equation without having any multiplication is not possible, right? So these three equations are not possible. Only dimensionally meaningful equation is this. Okay, simple. Now multiply 107.88 by 0.610 and express the result in correct number of significant figures. Now here, this is an interesting question where you actually don't need to multiply. Why? Because you can see that all the quantities have almost same answer. So if you multiply, you will get 65 point something. So what you are actually supposed to do in this question is to find the exact correct number of significant figures. That's it. Okay, multiplication is not what we are asked about. Okay, so when we are multiplying 2 digits, okay, the answer should be equal to the least number of significant digits possible, right? So how many significant digits are here? Here we have 5 significant digits. Okay, so 1, 2, 3, 4, 5. Now how many significant digits here? We have 1, 2, 3 significant digits, right? So this 0 is also significant because it is coming after decimal and it is specifically mentioned, so it will be it is coming after a non-zero digit, so it will be significant. So 3 significant digits in this case. Now how many significant digits should our answer have? We should have minimum number between 5 and 3. So what is minimum between 5 and 3? 3 is the minimum. So our answer should contain only 3 significant figures. Okay. So from there we can see that this number has 1, 2, 3, 3 significant digits. So correct answer will be option D. Clear? Okay, the least number of significant digits when you are multiplying. Okay, these the rules I taught during my lectures. There are different rules for addition and subtraction, and there is a different rule for multiplication and division. Okay, if you still have the confusion, you can go and check that video. Okay, now question number 5, what is the dimensional formula of power? Very simple question. Power is basically work done per unit time. Okay, work done is nothing but force times displacement divided by time. What is the dimension of force? Force is mLT to the power minus 2. I said always remember the dimension of force. Okay, now what is the dimension of displacement? It's L. Here S is divided, so what is the dimension of S? It is time. So now if you combine them, you will get mL square t to the power minus 3. If you don't know anything, you just remember the dimension of force. It will be very helpful, and all the other quantities, if you can find the formula behind the quantity, then you can find the dimensional formula as well. So what is the dimensional formula? M to the power 1 L square t to the power minus 3, right? M to the power 1 L square t to the power minus 3. There are no repetition. Yes, so this is the correct answer, right? Now let's move on to the next question. The vernier scale of a travelling microscope has 50 divisions which coincides with 49 main scale divisions. If each main scale division is 0.5 millimeter, then the least count of the microscope is. This is related to your experimental observation. So what is the least count? Least count is 50. Okay, so what is the maximum number is 50 and it is matching with 49. So we know that the formula is 1 minus 49 by 50 times 0.5. Okay, this is the formula. You should remember that 1 minus coinciding number divided by total number of division times the least count of the scale. Okay, this is the least count of the main scale. So what is the least count of the vernier scale? This is the least count of the vernier scale. So it will be 1 by 50 times 0.5. Okay, millimeters. Remember that the answer will be in millimeters because it is given in millimeters, right? So you can cancel that 10, 0.1. Okay, so the answer will be 0.01 millimeters. So as you can see, the answer is option A. Okay, very simple problem, simple answer. If you remember your experimental observation from your PU1, then you can solve this question. Now next question, the dimension of Planck's constant equals to that of. This is a very common question. The dimension of Planck's constant is equal to dimension of angular momentum. Okay, very simple. If you want to prove that, you can do that by individually finding the Planck's constant. Planck's constant is nothing but E is equal to h nu, energy is equal to h nu. Here h is Planck's constant, and momentum, angular momentum is I omega. Okay, I is nothing but generally mr square omega. If you put all the units, okay, frequency is 1 by time. So Planck's constant is E by nu. You can find the dimension of this. You can find the dimension of this. Then you can find the. You can check that if they are equal or not. Okay. Now let's move on. Which of the following is a dimensionless quantity? So force divided by acceleration is not a dimensionless quantity. We know that force equals to mass times acceleration, so it is not a dimensionless quantity. Okay, velocity by acceleration, definitely not dimensionless quantity. Velocity has only one time divided, acceleration has 2 times divided, so this is not a dimensionless quantity. Volume by area is also not dimensionless. Volume has L cube, area is L square, so definitely not dimensionless. Energy and work. Okay, energy is the ability to do work. So energy and work both have same units. So that means basically they are, on the other hand, they are same quantities. So energy and work definitely will have same units, so they will cancel and it will give you a dimensionless quantity. So just compare the units if you are doubtful, and check if they are giving you dimensionless quantity or not. Okay, now let's move on. Question number 9. An object is moving through a liquid. Okay, the viscous damping force acting on it is proportional to the velocity. Then the dimensions of constant of proportionality is, okay, very difficult question, but as I said, what is the main thing? Viscous damping force. Force is important. Okay, no matter what type of force, they will always have the dimension of mLt to the power minus 2. So dimension of force will always be mLt to the power minus 2. Maybe it's a viscous force, maybe it's a frictional force, maybe it any type of electromagnetic force, whatever type of force it is, as long as it is a force, okay, it will have the same dimension. Does not matter what type of force it is. If it is a force, it will have the unit of Newton, it will have the dimension of mLt to the power minus 2. Okay, now that equals to the constant of proportionality times. So basically what the question says, the force is basically proportional to the velocity. Okay, so if you remove the proportionality sign and write it in an equation, then there will be a proportionality constant. So basically they have asked you what is the dimension of this k. Okay, so what is the dimension of velocity? Velocity has Lt to the power minus 1. Okay, so dimension of k will be m L to the power 1 here, L to the power 1 here, so 1 minus 1, so L to the power 0, t to the power of minus 2 here, t to the power of minus 1 here, so minus 2 plus 1, so t to the power minus 1. Okay, so dimension of this will be m L to the power 0, t to the power minus 1. Right, so correct answer is option C. So be careful, here they have given L1, so don't by mistake mark this as correct. Okay, this one will be correct. Okay, now let's move on. Next question, the respective number of significant figures for the numbers. Okay, what are the significant figures for each of these numbers? So 1, 2, 3, 4, 5. This 0 is sandwiched, so this is significant, so this has a 5. Now what is the significant number for this? This has a significant number 1. These zeros are after decimal, but there is no non-zero decimal in between, so these numbers we do not count, so only 3 we will count, right? So this has a significant figure 1. Now what is the significant figure for this? 1, 2. Okay, this is not significant, only 2 significant digits here. Okay, so 5, 1, 2. 5, 1, 2 is correct answer is option A. Simple question. Now let's move on to the next question. So all the dimensionless units and dimension questions are finished. Now let's move on to a slightly more interesting chapter, that is motion in a straight line. The displacement x in meter of a particle having mass m in kilogram moving in one dimension under the action of force is related to the time t in second by t equals to square root of t plus square root of x plus 3. So time t is given as square root of x plus 3. Okay. Now the displacement of the particle when its velocity is 0. So first we have to find the velocity equals to 0 at that time, what time the velocity is 0, and at that time we have to find the displacement. Here x itself is the displacement. Okay, so first of all you have to find the velocity. To find the velocity we have to make x independent. Here x is dependent, right? So we have to make x independent. How we can do that? We can make x square root of x equals to t plus 3. Okay, or x equals to t plus 3 whole square, or t square plus 6t plus 9, right? This is the displacement. Sorry, I made a mistake here. What mistake I made? Here it should be t minus 3, sorry. This was plus here, so it will be minus here. So these will be minus as well. So this is minus, this is minus. Now what we have to do, we have to find where velocity is 0. So to find velocity, what we know? We know that velocity is dx by dt. that is instantaneous velocity. So let's find dx by dt. So dx by dt is nothing but 2t minus 6. This is a constant, so it will be 0, right? There was a square here, so square come down, 2t, and this was only power to the power 1, so that gone, so only 2t minus 6. Now velocity equals to 0 means this will be equals to 0. So what else? 2t minus 6 equals to 2t equals to 6. So if 2t minus 6 equals to 0, then 2t equals to 6 or t equals to 3 seconds. Now they have asked you to find the displacement when velocity is 0. So to find the displacement x, we have to put this value of t in this equation, right? In this equation. So x equals to 3 minus 3 whole square, that is 0. Okay, so displacement will be 0 meter at when the velocity is 0, even though time is not 0, but displacement will be 0. Okay, clear? So displacement will be 0 when the velocity is 0. Now let's move on to the next question. A body is moving along a straight line with initial velocity v0 and acceleration a. The average velocity of the body over the given time interval is. So final velocity is given v, okay, and it starts with the initial velocity v0, okay, and acceleration a. Okay, the average velocity of the body over the given time interval is t. So first we need to understand what is the average velocity. Average velocity is total displacement divided by time, right? This is the average velocity. Now how can we find the displacement? So what is given? Initial velocity is given, final velocity is given, okay, and acceleration is given. So we know that v square equals to u square plus 2as. So this is the equation that we are going to use to find the displacement, because all these quantities are given except displacement, right? So if time was exactly given, we could have used s equal to ut plus half at square, but that will be a little bit more complicated equation. For this, in fact, you can check the options as well where v0 is used. Okay, v0 and v both are used. If v was not given, then we could have used that equation. Here v is given. So 2as equals to v square minus v0 square, or s equals to v square minus v0 square divided by 2a. So average velocity is displacement by time, that is v square minus v0 square by 2at. This question came in 2023, so correct answer will be v square minus v0 square by 2at. Okay, so based on the options given, we have to choose which formula to be used here. Okay, so now let's move on to the next question. For the body moving along a straight line, the following Vt graph is obtained. According to the graph, the displacement during uniform acceleration is greater than that of during uniform motion. Uniform acceleration is less than at during uniform motion. Uniform acceleration is equal to that. This is not at, this is that. Okay. Uniform acceleration is equal to that during uniform motion. Uniform motion is 0. Okay, so the displacement you are trying to find out. Okay, and which case displacement is more, that is our concern. So from the option it is clear that we are trying to find displacement, and we have to find in which case the displacement is more. So assuming that this is t, 0, this is t, this is 2t. Okay, so what is the displacement in this case? So as you can see, this is a rectangle, okay, and this is not a rectangle, this is a parallelogram. Not even parallelogram, this is, okay, if you consider this, then it will be a rectangle of this equal area, but this area is not included in this case, right? This area is not included. So this area not included means only included part is this. So this is more than this, right? So if this part was included, then it would have been having the same area. So the area is different means this is displacement, suppose this is displacement d1, this is displacement d2. Now which part it is accelerating? So as we can see that velocity is increasing here. So velocity increasing here means this is an accelerated motion. So this is a uniform accelerated motion. Here the velocity is constant, so this is uniform motion. This is normal uniform motion, this is uniformly accelerated motion, right? So displacement is more for uniform motion. Okay, uniform acceleration is less than that during uniform motion. Okay, so uniform acceleration is less than that of uniform motion. Only by seeing the area you can find that, okay, this area is less, this area is more. So basically uniform motion should be more than that of the uniform acceleration, right? Now let's move on to the next question. At a metro station, a girl walks up a stationary escalator in 20 seconds. If she remains stationary on the escalator, then the escalator takes her up in 30 seconds. Okay, so the time taken by her to walk up the moving escalator will be. So first, there is an escalator. I hope everyone is familiar with escalator. If you are not, then go to any mall. Okay, and if you are living in Bangalore city, you can go to any metro station. There will be escalator. Okay, even in modern railways also they have escalator in many stations nowadays, right? So now what is escalator? Escalator is a moving stair. Okay, so initially the stair was not moving, so the girl walks up and it took her 20 seconds. Suppose the length of the escalator, say L. Okay, so what is the velocity of the girl? So it takes L distance, L meter. Okay, she walks up L meter in 20 seconds. Okay, so the velocity of the girl is given by L by 20. Now the same escalator, when the girl is not moving, same escalator takes 30 seconds to reach from here to here. So what is the velocity of escalator? Velocity of escalator is L by 30, right? Now when the escalator is moving, girl is also moving, so their velocities will add up. So when both of them are moving, the total velocity is nothing but Vg plus Ve. Okay, this is the total velocity, so let's add them. L by 20 plus L by 30, LCM is 60, L is common. Okay, L is common, so 3 plus 2, so it will be L into 5 by 60 or 12. Okay, so the average velocity, total velocity will be L by 12. Now how much time it will take for them to reach the top? So how much time it will take? Time will be displacement divided by velocity now. Okay, from here we know that velocity is S by T, so T will be S by V, right? So we can find L divided by L by 12. Okay, so 12 will go up, so it will take 12 seconds. 12 seconds to reach the top. So correct answer is option A, right? Now let's move on to the next question. A body falls freely for 10 seconds. Its average velocity during its journey. Another interesting question. Many students think, okay, 10 seconds, so it is initially 0, final velocity, let's calculate final velocity and calculate average velocity. That is not the process. So what is the process? Average velocity, always remember total displacement by total time. Okay, so when you drop an object, okay, how can you find the displacement? Okay, initial velocity is 0. Okay, and we know that S is equal to ut plus half gt square. In case it is falling freely, okay, the acceleration, only acceleration acting on it is the acceleration due to gravity, that is g. So u is 0 here, half g is 10. Okay, and time taken is 10 seconds. 10 seconds square, that is 100. Okay, so here we can say that S equals to 500 meters. Okay, S equals to 500 meters. Now what is the average velocity? Average velocity is total distance traveled divided by total time taken, 10 seconds. Time is already mentioned, so 50 meter per second is the average velocity. So 50 meter per, everything will be to the power minus 1. Okay, this will be to the power minus 1. Okay. So correct answer is 50 meter per second. Okay. Now let's move on to the next question. A car moves from A to B with a speed of 30 km per hour from B to A with a speed of 20 km per hour. What is the average speed of the car? So car start at say A, move to place B with 30 km per hour, and while coming back it came back with a speed of 20 km per hour. Now assume that the distance between A and B is x kilometer. Okay. So what is the time taken when it is going from A to B? Time taken to go from A to B is x divided by 30. Okay, this is the time taken to reach A to B. Time taken to reach B to A is x by 20. Right? What is the total time? Total time is TAB plus TBA. So basically x by 30 plus x by 20, that is equals to x by 12. If you remember, in the same problem we solved few problems back, 2 problems back, there it was 20 and 30, so 60 will be LCM, 5 will come up, so it will be x by 12. Okay, now what is the total distance travelled in this case? Total distance travelled, okay, equals to first time it is going from here to here was x, and from here to here is another x. Okay, so total distance travelled is 2x. Okay, now remember this is average speed. If it was average velocity, then the answer would have been 0. Okay, because it starts from A and it comes back to A, that's why average velocity would have been 0. But because they have said average speed, okay, only thing that we need to consider is total distance travelled. Total distance travelled is 2x. So average speed is total distance travelled by total time. So that is equals to 2x divided by x by 12, that is 24 kilometer per hour. Okay, so 24 kilometer per hour. If you have just taken, added them 30 and 20 and divided by 2, you would have got the wrong answer. So that's not, you should calculate the average speed. Average speed or average velocity, to calculate it, you have to find the total time, you have to total displacement, and then based on that you have to calculate the average velocity. Similar for speed, you have to first calculate the total distance travelled, then you can calculate the average speed, right? Now let's move on. Question number 17. The position of a particle moving on a straight line path is given by x equals to 5 plus 3t plus 7t square meter. Its acceleration at t equals to 2 seconds. So they have asked you to find the acceleration. So displacement is given, okay, 5 plus 3t plus 7t square. Okay, so what is the acceleration? To find acceleration, first thing you have to do, you have to find the velocity. Velocity is dx by dt, right, equals to, if you do the differentiation, this one will be 0, this one will be 3, this one will be 14t, right, this one will be 14t, 2 will come down, so 2 7s are 14t. Now what is the acceleration? Acceleration is dv by dt. So dv by dt, that means this will be 0 and this will be 14 only, so acceleration is 14. So as you can see, the acceleration is uniform, okay, acceleration is constant. So no matter whatever time it is, it will always be 14 meter per second square. Be careful about units. Acceleration has unit meter per second square. In case they ask you, give you some other units, so in that case you have to be careful. Okay, now let's move on to the next question. An object is dropped from rest. Its speed v changes in the following from. Now if you see, the graph is not velocity time graph, it is velocity distance graph. Okay, so be careful what information is given to you. So what is the relationship between velocity and distance? The relationship between velocity and distance is v square is equal to u square. Now u is 0 in this case because it is dropped, u square plus 2as, so 2gs. G is the gravitational acceleration, because when you drop it, it changes with the gravitational acceleration, right? So v square equals to 2gs. Now this is similar to y square equals to 4ax. What is this equation? This is the equation of a parabola, okay, and as you can see, the parabolic equation can either be, now there are two types of parabola, either it can be a parabola like this or it can be like this, right? So both of them can be parabola, right? So now which parabola it will be? So what is y square equals to 4ax parabola gives you, okay? So y square equals to 4ax parabola will be like this. Okay, so this is the parabola, not this one. Both of them are parabola. Okay, but y square equals to 4ax parabola is that one. Okay, because it is y axis, and as you are increasing x, y is increasing, okay, in the square range. So this will be the value, right? Not this one. This is x square equals to 4ay. If that is the parabolic equation, then it will be the equation. So remember that along x axis you have displacement distance s, along y axis you have velocity v. Okay, so basically this equation is comparable to y square is equal to 4ax equation. Okay, so this will be the answer. Now let's move on to the next question. The displacement of a particle is given by x equals to t minus 2 whole square, where x is in meters and t is in seconds. The distance covered by the particle in first 4 seconds. This is a little interesting question, a slightly difficult question for KCET level. Let's see. So here x is given as t minus 2 whole square. Okay, so t is minus 2 whole square. So what is the velocity? Velocity will be dx by dt, right? So dx by dt equals to, if you know how to do differentiation, it will be 2t minus 2, right? So this is the differentiation. I hope you are aware of that. Now this is a very interesting question, okay? So here they have asked you to find the displacement from 0 to 4 seconds, right? Between by first 4 seconds means 0 to 4 seconds. Okay, so here you can see that there is a point between them where velocity becomes 0. So this is not so simple. So where the velocities become 0, so let's put velocity v equals to 0, that is 2 into t minus 2, that is t equals to 2 seconds. At t equals to 2 seconds, the velocity becomes 0, right? So what we have to do to find the displacement, because if you plot the graph, okay, if you plot the graph, it will be coming like this. Okay, so this will be somewhere initially the value was negative. So as you can see, initially velocity was negative. When t equals to 0, velocity was minus 4, right? So velocity was minus 4 and then it becomes 0 and then it keep on increasing. Now if you find the displacement is normal method, then it will be there, you will find the displacement to be negative. Here the displacement will be positive. Okay, so distance covered you cannot calculate using normal method. So what you have to do, you have to find the displacement in two halves. First you have to calculate the displacement for time t equals to 0 to 2 seconds. Okay, then from 2 seconds to 4 seconds. So basically what you have to do, you have to find the two types of displacement, and so displacement is integral. You know that displacement is integral v dt, right? Integration of v dt gives you the displacement. So from 0 to 4 seconds. Now using the law of v dt plus, this is modulus sign, integral 2 to 4 v dt. Okay, this is negative, this will come out to be negative value, so that's why we have put this modulus sign. So whatever value we will calculate, that will be converted into positive value. Okay, so let's first calculate the 0 to 2 integration. Okay, so 0 to 2, what is v? V is 2 t minus 2. Okay, dt, this is the x1 or s1, let's call it s1. I hope you are familiar with this division, right? Integration of a to b can be written as a to c plus c to b, where c is in between a and b, right? Where c is between it is greater than A but less than B, like that. Okay. You know, I hope you are aware of this kind of definite integration properties. Okay, that property we are using here. Okay, if you are not aware of this property, in that case what you have to do, you have to calculate the individual displacement in both cases. You have to calculate the acceleration, and then from there you can calculate the area of this portion, area of this portion, and then you can add that. That is also fine. Okay, now what is the displacement in this case? This will be integration of t is t square by 2, integration of 2 is 2t, and the limit is 0 to 2. Okay, so it will be first you put the value of 2, so it will be 4 by 2 minus 2 into 2, that is 4. Okay, 0 is always 0, so 2 times 4 by 2 is 2, 2 minus 4, that is minus, so it is 2 times minus 2, that is minus 4, right. So this will be minus 4, but while using the value, what we will do, we will only use the plus value, right. As I said, we will take the modulus of that. So modulus of displacement, negative displacement will be plus 4. Similarly, if you do the integration, you can check, okay, the same function, the limit will be now 2 to 4. In that case, you will get another 4. Okay, so the total displacement will be 8 meters. Okay, you can solve this either geometrically or mathematically, whichever way you think you are comfortable with, but the correct answer will be 8 meters. This is little tricky question, not exactly of the level of KCET exam, but this is for a perfect example of a JEE mains exam. Okay, JEE mains exam, this type of questions will definitely come. Okay, not exactly this problem, but this type of question will come. Now let's move on to the next question. Question number 20. The velocity time relationship of a particle starting from rest is given by V equals to kT, where k is equal to 5 meter per second square. The distance travelled by the particle in 4 seconds is. So here velocity is given by kT. We know that there are 2-3 different ways to solve this question. The easiest way is displacement equals to Vt V dt. Okay, displacement is from 0 to 4, right. So V is kT dt 0 to 4, k value is given 5, so it will be 5 t dt 0 to 4, t dt means x dx. What is the integration of x dx? T square by 2 0 to 4, right. So 5 times t square is 16 divided by 2, 0 is obviously 0. So 5 times 8 is equal to 40 meters. Okay, 40 meters is the correct answer. Simple question. This is an easy question. Okay, if you know how to find the displacement, this is the easy question. Now next question 21. 2-point charges. Now from here onwards we are doing the revision of electric charge chapter. As I mentioned, electric charges was included in this week's KPL. So if you have not studied, go back, revise this chapter. This is from your second PU. So I hope your score will be better from here onwards. 2-point charges plus 2 coulomb and plus 6 coulomb repel each other with a force of 12 Newton. If a charge of minus 2 coulomb is given to each of these charges, what will be the force now? Interesting question. So you don't need to do any mathematics in this case. Just read the question twice. Then you will realize this is a very easy question. So 2-point charges, one of them was plus 2 coulomb, another one was plus 6 coulomb. Okay. Now each of the charges are given now minus 2 coulomb. Right. So what is the net charge? Suppose the charge on QA was 2 coulomb, charge on QB was 6 coulomb. Now each of them were given a minus 2 coulomb charge. So minus 2 was given to this, minus 2 is given to this. So this will become 0, this will become 4. So what is the force between 0 and 4? 0 and 4, the force between them will be 0. Okay, no need to do mathematics. If you just read the question paper once or twice, you will be able to answer this question. This is a simple question. Okay, next move on. 2 point charges are 3 meter apart and their sum is 8 microcoulomb. The force of repulsion between them is 0.12 Newton. Charges are. So what is the thing? They have said you have two charges, QA again, QB, okay, and the sum of them is 8 microcoulomb. Okay, so the force between them is given by K, Q1, Q2, QA, QB divided by R square. Now what is the distance? Distance between them is 3 meters. Okay, what is K? K is 9 times 10 to the power of 9. QA, QB. Okay, and distance is 3 meters. So 3 meters means 3 square is 9, right? Here 9 cancels. So as you can see that what is this value of the force? Value of the force is 0.12. Okay, so QA, QB times 10 to the power of 9. Right? Now if you see, the charges here are only digits. There are no other digits involved here. So the charges should be such that if you multiply them, okay, they should be of the order of 12. Okay, so yes, there will be there because they are nanocoulomb charge or microcoulomb charge. Based on that, 10 to the powers can be adjusted. But if you adjust the 10 to the powers, then this should be given as 12. Right, now check the options. How many options you can find where the multiplication giving you 12? This is the logical solution. You can do all the mathematics, you can put the value here, you can solve them, okay, by subtracting QA, QB and solving a second order equation, but this is not that. Okay, this is a KCET level question. So in KCET level question there is always a possibility that you might find logical reasoning, logical answer that you can answer the question quickly. So here 12 is the multiplier between QA and QB. So here 4 4s are 16, not possible. 6 2s are 12, that is possible. 5 3s are 15, not possible. 7 1s are 7, not possible. So only logical answer is 6 microcoulomb and 2 microcoulomb. You can take them as x, then you can substitute that and then you can solve it for x, you will get the same answer. Okay, so if you want to do the mathematics, you do it, but this problem can be solved even without doing mathematics. So those who are a little bit weaker in mathematics, then still you can answer if your logical thinking, logical reasoning is clear, right? So this is the way to solve this question. Now question number 23. Two charges 4q and q are 3x apart. So distance between them is 3x. A charge capital Q is placed at a point on the line joining so that the system of these three charges remains in equilibrium. So we have two charges 4q and small q, okay, and they are 3x apart. Distance between them is 3x. Okay, a charge capital Q is placed at a point somewhere, capital Q charge is placed, okay, at a point on the line joining so that the system of these three charges remains in equilibrium. So the system is in equilibrium, then the distance of capital Q from 4q. So what is this distance? Suppose this distance is, I am saying, A. So they have asked you to find the distance A. So to find this case, what you have to do? You have to consider the point Q itself. Okay, so what are all the forces acting on this charge Q? So first of all, the charge Q should be negative charge, okay, because these two charges are positive, so Q should be negative charge, or if because the sign of small q is not given, if the both charges are negative, then Q will be positive. So basically the polarity of capital Q will be opposite to that of these two charges. Okay, so this charge will be attracting it in this direction, this charge will be attracting it in this direction. Okay, so if this distance is A, what is this distance? This distance will be 3x minus A, right? So this distance is A, this distance is 3x minus A. Total distance is 3x and it is kept between the charges, not along the line any point, right? So it is kept exactly somewhere between. So now what is the force on Q due to this charge? Force on Q due to 4Q charge is K 4Q capital Q divided by A square. What is the force on capital Q due to small q charge? K small q capital Q divided by 3x minus A whole square. Right? Now, if the system is in equilibrium, the net force should be 0 on all the charges. So net force on capital Q will also be 0. So net force in capital Q is 0, means 4Q should be equals to 4Q. Okay, because the sign is opposite, so there will be there will be 1 plus 1 minus, so they will cancel. So these two forces will balance each other. Right, these two forces should balance each other. So let's put the value capital K, Coulomb constant K, 4Q Q divided by A square equals to Coulomb constant K small q capital Q by 3x minus A whole square. Okay, so what you can do, let's cancel whatever is possibly cancelable. Okay, K cancels, small q cancels, capital Q cancels, so here remains only 1. Okay, so now do the cross multiplication. So do the cross multiplication, we get 3x minus A whole square times 4 equals to, this will go here, this will go here, right? This is the cross multiplication, so it will be equals to A square. Okay, now what we will do, do we need to break the square and solve a complicated equation? No, there is an easier way to do it. What we will do, we will take the square root of all the terms. Okay, so square root here, square root here. Okay, so if you take the square root of this term, it will become 3x minus A. If I take square root of 4, it will become 2. Square root of this is A. Okay, simple. So it will be 6x minus 2A equals to A. Now remember that here x is given. Okay, A is not given. A we assumed. So 6x equals to 3A, or A equals to 6x by 3 equals to 2x. Okay, so the distance will be from 4Q will be 2x. Okay, because we have assumed the distance from 4Q is A. So if you calculate A, then we will be fine. So distance will be 2x. Okay, now let's move on to the next question. A charge capital Q is placed at each opposite corners of square. Okay, a charge small q is placed at the each other two corners. So basically there is a square. Okay, and you have placed capital Q on these two corners, suppose, and small q on these two corners. Okay, now if the net electrical force on capital Q, net electrical force on this capital Q suppose is 0, then what is the ratio of capital Q by small q? Okay, or what is the value of capital Q by small q? Interesting question. So what is the force acting on this? This is a not simple question. Even though the problem looks simple, it is not so simple because it involves vector. Okay, why? Because suppose, what is the force between these two charges? Force between these two charges, so both of them are assuming all the charges are positive. Okay, we are assuming all the charges are positive. Okay, so it will repel along this direction. Now this will repel along this direction. Okay, and this charge will repel it along in this direction. Okay, can it create an equilibrium? If both of them are positive, then these two forces will again be added. So these three forces cannot create equilibrium, right? Because as you see, everything is on this direction. So net resultant of these two forces will be along this line again. So then you have to add them. So it will be not possible to make any equilibrium. To make it equilibrium, what you have to remember that there should be an opposite force to this. Now capital Q and capital Q both has to be of same sign. right? Small q and small q should have the same sign. So both of them should be opposite polarity so that they are attracting them. Okay, so the net force of these two forces is along in this direction. Okay, so the net force of these two forces should be in this direction, then only there is a possibility that this the combined force can balance this force, right? So first, what is the combined force of first let us find this force. Okay, so suppose this distance is a, this distance is a, this is a, so then the diagonal will be a root 2. We know that diagonal of a square is a root 2. So what is the force between these two charges? Force between QQ is given by K QQ divided by distance square. Distance is a root 2. Okay, so it will be K Q square divided by a square times 2, or let me write it 2a square. Okay, so this is the force between these two charges. Now what is the force between small q and capital Q? Force between small q and capital Q, take any one of them, okay, what is that value? That value will be K Q capital Q divided by the distance between them is a, so a square. Okay, both of them are a distance, right? So this is the force between these two charges. Now what is, these two forces will be same, so this is FQQ, this will be also FQQ magnitude wise. Now what is the resultant of these two vectors? This angle is 45 degrees, this is also 45 degrees, so the resultant will be 2FQQ cos 45. Cos 45 component from this, cos 45 component from this, so there will be a 2 factor. Okay, so let put that value. 2FQ is KQQ by a square cos 45. Cos 45 means 1 by root 2, right? So this is the two forces. Now these two forces should create equilibrium. How can they create equilibrium? If these two forces, suppose this is this force is say FA. Okay, now name it. So FA plus FQQ should be equals to 0. That is the condition for equilibrium. Or we can say that FA basically will be equals to minus FQQ, right? Minus FQQ. So what we have to do, we have to put the values. Okay, FA is this value 2KQQ by root 2a square equals to minus KQ square divided by 2a square. Okay, so a square cancels. Okay, K cancels, one of the Q is cancelled, and they have asked you to find the capital Q by small q. So take this small q on that side. I hope this will be easier for you. Capital Q by small q. Take the negative sign on this side, so negative. Okay, these two will go up, so it will become 4 by root 2, right? 2 2s are 4 divided by root 2. Okay, this q went to that other side. Now what is 4 by root 2? 4 by root 2 is nothing but 2 root 2, right? 4 by root 2 is 2 root 2. So minus 2 root 2 is the answer. Okay, interesting problem. I hope you enjoyed this. Next question is 25. If the charge on the body is plus 1 Newton nanocoulomb, then how many electrons are removed from the body? So number of electrons removed from the body will be equals to charge equals to, from the quantization principle, charge equals to number of electrons removed times charge of 1 electron. So number should be equals to Q by E. What is Q? Q is given 1 nanocoulomb. 1 nanocoulomb means 10 to the power of minus 9. Okay, charge of an electron is 1.6 times 10 to the power of minus 19. Okay, so it will be 10 to the power of 10 divided by 1.6, or you can write this as 10 times 10 to the power of 9 divided by 1.6. So we have taken 110 out, so that the answer is not in fraction. So 10 by 1.6 is 6.25. Okay. Now you might be wondering how I got that answer, because all the options are 6.25, right? So definitely 10 by 1.6 will be 6.25, right? Now only thing that you have to careful is about the 10 to the powers. So 10 to the power 9 is given, so 10 to the power 9 is the correct answer. Okay. This is a very common simple question. You can even remember this question. This question also comes sometimes in your MCQ for board exam as well. Okay. Now let's move on. Next question. The magnitude of point charge due to which the electric field 30 centimeter away has a magnitude of 2 Newton per coulomb. So electric field, what is the formula for electric field? E equals to KQ by R square. Here R is given 30 centimeter, or equals to, what you can do, 30 times 10 to the power of minus 2 meters. Okay, 1 0 you can reduce even, 3 times 10 to the power of minus 1 meters. Okay, so now let's put the values here. Electric field E is given as 2 Newton per coulomb. Okay, and charge value is not given. We are trying to find charge. What is K? K is 9 times 10 to the power of 9. Q we are finding, and R is given this 3 times 10 to the power of minus 1 whole square. Okay, so Q will be equals to 2 times 3 times 10 to the power of minus 1 whole square, cross product. Okay, and this will come down 9 times 10 to the power of 9. Okay, so let's simplify. 2 times the square of this will be 9 times 10 to the power of minus 2, minus 1 whole square, so minus 2 divided by 9 times 10 to the power of 9. This 9 cancels, so it will be 2 times 10 to the power of, this 9 will go up and will become negative, so it will become minus 2 minus 9, that is minus 11. So charge will be 2 times 10 to the power of minus 11 coulomb. Okay. Now when a soap bubble is charged, what will happen? When you charge a soap bubble, all the charges will reside on the surface, because inside there is air only. Okay, so and these charges will repel each other. Inside there is air, so air cannot have any charges. All the charges will be slowly moved to the surface. We know that charges reside on the surface. So and then they will repel each other. They will repel each other. They are repelling each other means the radius of the bubble increasing. So its radius increases. Okay, clear? So because they are repelling each other, slowly the bubble will try to expand. Okay, so its radius will increase. 28. 2 point charges of 0.1 microcoulomb each are placed at a separation of 0.2 meter in air. Okay, so 2 point charges each of 1 microcoulomb, 0.1 microcoulomb separated 0.2 meter in air. The electric field strength at the point midway between the charges. So electric field strength midway between the charges. Now both of them are positive. Okay, both of them are positive, and they have asked you to find the midpoint, electric field at the midpoint. So at the midpoint, electric field due to this charge will be in this direction. Okay, in this direction, and electric field due to this charge will be in this direction. Okay, so both of them will cancel each other. Both of them will have equal magnitude, because both of the charges are equal in magnitude, so they will cancel each other. So at the center the the electric field will be 0. Okay, clear? At the center, if the both charges are of same magnitude, okay, then the electric field at the center will be 0. Next question. An electric dipole is kept in non-uniform electric field. Okay, it generally experiences non-uniform electric field means electric field varies from point to point, right? So when you keep a electric dipole, okay, there will be a force acting on this, there will be force acting on this, and so there will be a torque. Definitely there will be a torque, but these two forces are not equal in magnitude. Okay, not equal in magnitude means they will not balance each other. So there will be a net force in the direction of whatever direction of non-uniform electric field, there will be a force as well. So it will experience a force as well as a torque. Okay, so a force and torque both it will experience. Now let's move on to the next question, last question. Pick out the statement which is incorrect. So again here you have to pick the incorrect statement. That means 3 statements are correct, only 1 statement is incorrect. That incorrect statement you have to be careful about. The electric field lines forms closed loop. The first statement itself is wrong. Okay, so correct answer is option A. Electric field lines does not form closed loops, only magnetic field lines forms closed loop. Let's check the other options as well for guarantee. Field lines never intersect. Yes, correct statement. The tangent drawn to a line of force represents the direction of electric field. Yes, correct. Okay. A negative test charge experiences a force opposite to the direction of electric field. This is also correct. So these 3 statements are correct. Only this statement is incorrect. So for our answer, question number 30 will be correct, right? So we have completed today's KPL as well as usual. So 9th KPL is over, 9th match is over, and if you are still waiting at the boundary, okay, and thinking that someday I will come to bat and I will score century, not going to happen. Okay, if you want to score century, then you have to start playing today only. Okay, so these are all practice matches. If you practice now, then only during the final match you can score century. So if you have not yet joined our channel, not yet subscribed to our channel, don't forget to subscribe to our channel, join our WhatsApp group and share this video with your friends so that more and more students join us and everyone can take advantage of this completely free series that we are going on, right? So I will see you with a new video tomorrow. Till then, bye bye.